Let z be a complex variable. For a counterclockwise integration around a unit circle C centered at origin, value of this integral, that is closed integral on curve C, 1 upon 5z minus 4 dz is equal to a pi I. So we need to find the value of a here. So in the problem we are given a unit circle, that means the radius. If I draw a radius from this point, from the origin, so this is equal to 1. So we are given a unit circle centered at the origin, and we need to take the integration in counterclockwise direction. That means the integration should be positive, and the integral that we need to find is closed integral on loop C, that is the circle, unit circle. So if this unit circle, this is z, mod z is equal to 1, because this is z plane, that is known as complex plane. Okay, so the integral 1 upon 5z minus 4 into dz, and the value of this is already given to us is a pi I, and we need to find the value of a here. So we can also write this integral. This integral can also be written as, on loop C, let's take 5 common in this denominator, so we can write 1 upon 5 in the numerator divided by z minus 4 by 5, okay, into dz. So we can also write this like this. So if we observe this equation, the denominator, so the denominator is z minus 4 by 5. If we equate it to 0, we get the value of z as 4 by 5. That means at z is equal to 4 by 5, there exists a pole, right? So let's write here, there is a pole at this z is equal to 4 by 5. Now, according to Cauchy's integral theorem, we can write closed integral on loop C, f of z divided by z minus z naught into dz should be equal to 2 pi iota f of z naught. And here we see here that z naught value is 4 by 5, right? So this integral, this is closed integral on loop C, 1 by 5 upon z minus 4 by 5 dz. Now if we compare this equation and this equation, we can see that z naught is equal to 4 by 5 here, right? So this integral we can write 2 pi I, and f of z naught we need, so z naught we have 4 by 5 and we need f of z naught. See, f of z here, if we compare these two equations, we will find that it is 1 by f of z comes out to be 1 by 5. So that means it does not depend on z, and this is not possible here, right? So we can write f of z will be equal to 1 upon 5 limit z tend to 4 by 5 z minus 4 by 5 divided by z minus 4 by 5, and this will ultimately be 1 by 5. Okay, so we can write here into 1 by 5. Okay. So, and the value of this integral, it's given in the problem. So here it's given a pi I. Let's write it here. So a pi I is equal to 2 pi I into 1 by 5. We can cancel out I from here. Pi also we can cancel out. So a will come out to be 2 by 5. Okay, and this is our final answer. Now let's go back to the problem and match with the given options. So we can see option A is the correct choice here. To get detailed information on Cauchy's theorem, you can refer to the NPTEL course lecture number 3, Cauchy integral theorem on mathematics 2 by Dr. Tanuja Srivatsava of the Department of Mathematics, IIT Roorkee.